Gradient vector always comes as confusion. Means what is relationship between gradient vector and gradient? So there are these are two things. So if I have a line, okay, so there is a line, okay, this is x-axis, this is this is x-axis, and this is y-axis. Suppose like that. So this is xy plane. This is x-axis and this is y-axis. This is xy plane. If that is true, then my finger, what you see, is the origin. Okay. Now there is a line like this. Okay. So equation of the line is y equal to x to the power 4. X to the power 4. Okay. So it would start like this and it would go like this. So y equal to x to the power 4. What is gradient surface or gradient line? What is gradient vector? So generally we can say gradient normal vector, but gradient vector surface and gradient surface, gradient 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 normal vector or gradient vector, one thing. Gradient surface or gradient surface vector, that is another thing. Okay, so these two things I can talk more, but it will be more confusing. These two things will talk. Gradient vector, that is also gradient normal vector, and gradient surface vector, that is also tangential surface vector. So, gradient vector or gradient normal vector, gradient surface or gradient surface vector, tangential surface vector. These two things we will talk. Okay. Now, y equal to x square. Suppose this is a equation of a line in 2D. So in xy plane. So in xy plane, we have y equal to x square. This is equation of a graph. This is what we can say. Okay, so tangent, gradient, tangent, gradient at any point would be different. So if this is x-axis and if this is the line, then here the tangent is sharp, whereas when it starts here, tangent is flat. So at every point, the gradient, tangent, what we calculate, okay, so or derivative. So at that point, every point, the tangent is different. So when we have a line called y equal to x square, 1 is 1, 2 is uh, 2 is how much it would be? 64. 2 into 2, 4 into 2, 8, 16. Okay, so when x is 2, y is 16. When x is 3, then y is 27 into 3. Okay, then it would come as 27 into 3, 7 into 3, that is 81. Okay, and now I cannot correct. 4 would be 4 into 4, 16, then 64, and then it will go in 200. So the graph of y equal to x square would be like this. Okay. Now at the beginning, if I calculate the gradient, it will be like along the x-axis, but afterwards it will be vertical. So at each point, the gradient is different. Suppose I want to calculate at point 1. Okay. So I want to calculate at point 1. Now dy by dx is 4x cube. Y equal to x to the power 4. Then dy by dx is 4x cube. If that is true, then equation of the tangential line is y minus y0 equal to dy by dx or m x minus x0, or at any point ab, okay, at any point ab, then equation of the tangent would be fab plus dy by dx at ab x minus a. Y minus y0 equal to m y minus y0 equal to m x minus x0, where y0 and x0 are interception of the line at y-axis and x-axis provided other is 0, or the line is passing through x0 y0. Okay, if we are calculating at ab, then y minus b equal to m is dy by dx, y minus b equal to m x minus a, y equal to y equal to b, y equal to b plus b I took other side, y minus b equal to m x minus a, y equal to b plus m x minus a, y equal to b is nothing but fa, b is nothing but a function of x where x is a. So y equal to fa plus dy by dx at x equal to a x minus a. Now I won't complicate this much. So we can kind of suppose that the line is passing through origin. Okay, now it is simple. So interception at x and y are 0. Then y equal to mx. Y equal to m is 4x cube. Y equal to x to the power 4x. Y equal to x to the power 4 dy by dx is 4x cube. So the equation of the gradient line is y equal to mx. So y equal to 4x qx, where x I have to put a value. So y equal to 4aqx. So at any point A, the equation of the tangent line is y equal to mx, y equal to 4aqx. Suppose the point is, suppose the point is x, A is 1. I talked about 1 and 2. A is 1. The point A is 1. If that is true, then it will y equal to 4aq, y equal to 4x. At point 1, when x is 1, y is 4 times 2x. What is the equation of the vector? Now, we talked about gradient line. So if, okay, so things are confusing because it is little bit hard. But as I always say that if you learn things step by step, then more harder you go, more simpler you will feel and you will enjoy more. Okay, so that is the way we proceed. So y equal to x to the power 4 is the equation of the line. Whereas at any point, the equation of the tangent is y equal to mx, then y equal to 4x cube x. Now, at what point we want the tangent? So at point A, if we want the tangent, then y equal to 4aqx. Now A is 1. So y equal to 4x. So at A1, at x is 1, there the slope of the, so if this is the line where A is 1, then y is 4 times more to x. So this is something like this. So if this is the line where x is 1, then there the slope is like this, y equal to 4x. Now, what is the equation of the gradient? What is the equation of the tangent line? The equation of the tangent line where you want. General equation is y equal to 4 for AQX, where A is a point where you want the tangent. So this is the general equation we have deduced. Now y equal to 4aqx. What is A? A is 1, then y equal to 4x. This is the equation of tangential line. This is 2D. If we come to 3D, then this is equation of tangential surface. Okay, so this is gradient surface. This is gradient line. Gradient line is the equation of a line where the dependent variable y equal to independent variable x multiplied by the derivative, the partial derivative. So we have only one axis x. So partial derivative along x is, if it is x to the power 4, then 4x cube. So y equal to 4 aqx is the equation of gradient line when x is a, where the equation of the graph is 4, equation of the graph is y equal to x to the power 4. Then equation of the gradient line is y equal to 4 a to the power 4 a to the power 3x, where this line is the equation of a line at any point x equal to a. Okay. Now, where A is 1, the equation of the tangential line, equation of the gradient line, okay, is y equal to 4x. What is the vector form? There are two things. Equation of the line is different, and in vector form it is different. So y equal to 4x is the equation of the line, not the vector of the line. So we are talking about tangential line, gradient line, not the gradient line vector. Okay. So equation of the, if this is x-axis and this is the kind of equation of the line at any point a equal to 1, the equation of the line is y equal to 4x, where x is 1. Okay, what is in its vector form? So y is growing 4 times to x. If that is true, then the equation of the vector would be, if I say alpha I plus beta j, okay, it is two dimensional. So equation of the vector is alpha I plus beta j, where beta is 4 times to the alpha. So equation of the vector is I plus 4j. Okay, so equation of the any vector that falls on tangential line or gradient line is I plus 4j. Okay, because vector has a direction, it doesn't talk about intersection on any axis or something, direction and magnitude. Okay, so equation of the vector that is along the tangential line or surface line is I plus 4j. So we talked how. So we are talking about gradient vector and tangential vector. So our gradient vector normal and surface surface vector. So surface vector we calculated, tangential vector we calculated. A vector that is along the tangential line, surface line. What about gradient vector? Okay, if I say y equal to x to the power 4, I put in a complete equation, then it would turn out as x to the power 4 minus y equal to 0. Then if I calculate the gradient along x and y of this equation, it would turn out as 4x cube minus 4x cube, that is partial derivative along x axis, 4x cube, and minus 1 along y axis. So 4xqi minus j is the gradient vector. If x to the power 4 minus y equal to 0 is the equation of the line, okay, full equation of the line, then if you want to calculate the gradient vector, then it will come first. I have to find partial derivative along x-axis. So derive it along x-axis and keep y as constant. So 4x cube minus y gone. And now we have to derive along y-axis keeping x constant. So minus 1. 4 x to the power 4 gone. So x to the power 4 minus y equal to 0. So partial derivative along x-axis is 4x cube minus 4x cube, and partial derivative along y-axis is minus 1. So 4x cube I minus j. This is the equation of gradient vector. I have I plus 4j as equation of gradient surface vector. I have another equation as 4. Okay, now I said 4x cube I minus j is equation of gradient vector. Then at a equal to 1, it will come as 4I minus j. Okay. So one equation we have already received of the surface of the tangential surface vector or gradient surface vector, that is I plus 4j. Another equation we have got that is called gradient vector or gradient normal vector, that comes as 4I minus j, where x is equal to 1, because at every x things are changing. Can we do dot of these two? I plus 4j, 4I minus j. It is 0. This proves that gradient vector and tangential vector are normal to each other. So, if this is our tangential surface vector, then gradient vector is normal to this, because dot product is 0. Okay. So, I think it is enough. We will proceed in the kind of 3D. So when we kind of, or I think we can go ahead. So people have patience. So now in 2D, we have kind of, when we are talking about 2D, then we saw that the equation of the uh, gradient vector, equation of the gradient vector is I plus 4j, where equation of the surface vector is I gradient vector is 4I minus j, and surface vector is I minus 4j. If I do dot product, it comes to 0. So if I have a line like this at any point x equal to 1, if this is the tangent vector, then gradient vector is normal to this, because dot product is 0. Now question comes that if gradient vector and tangential vector are normal to each other, then can we calculate for 3D? Okay, I have really 3D. Okay, so I have cut it. So this is paraboloid. Okay, paraboloid in the sense, if this is origin, then it starts like this. Can you see? And it goes like this is what we are seeing x to the power 4 in single dimension. So it starts like this. Okay, and this is equation of 3D paraboloid. I believe I can cover this later. So uh, this is equation in 3D. Now we will see that how kind of if we have a pair of 3D shapes, then surface what is tangential surface and what is gradient surface? A vector, gradient surface, tangential surface, a vector along gradient surface. So gradient surface vector and gradient vector. So gradient normal vector also we can say. So how we can get gradient normal vector and gradient surface vector? So anyway, we have seen it is normal to, it is perpendicular to each other. So we'll use this concept that they are perpendicular to each other, and we'll see kind of many interesting things that how they move and how they can be useful.